Hi ladies, this is question 12, 2019, like Rachel requested, okay? So I'm assuming that you've read the question that I've put up. I will read the questions as we're going through, but I'm going to focus on writing the answers for the moment, and I'm going to approach this question like it's a H1 level question. I'm going to bullet point it because I think it's the most effective way of getting your point across, while making the examiner's life a little bit easier, rather than writing reams and reams of stuff that they have to go through and try and find the key points. Okay, so bear with me here. So the first question, A part 1, is what is meant by the term metabolism? So that's something we did early on in 5th year. So metabolism, so I'm going to write this, excuse my pajamas, you probably see my sleeve in my pajamas. Metabolism is the sum of all the chemical reactions in the body. Done. Okay, perfect. All right. Part 2. That was a 3-mark question. Part 2. Give an example of one anabolic reaction and one catabolic reaction in animals. Okay, so this is a 6-mark question. Anabolic. Now, do you remember what anabolic means? Anabolic means to build up. Think about anabolic steroids and that Jodie Marsh video that we watched I think it was in 6th year, okay? So anabolic is the process of building something up. So it's no harm in writing that in. So building materials up. Okay, an example of that in animals would be DNA polymerase. Okay, so they're asking us for a reaction. So that's the enzyme that is involved in that, and it's the synthesis of DNA is what it's involved in. Okay, now a catabolic, that's a little bit easier. You're more aware of more catabolic reactions, okay? That is the breaking down of materials. Your example there would be the catabolic enzyme would be something that's going to, for example, break down our food. So you could say any of the enzymes that are involved in that would be so amylase. Okay, breakdown of starch. Okay, so these are our enzymes. These are the actual reactions. Okay, so I'm hoping that's all right there. So that should be 9 marks out of 9 marks so far. Now we're on to part B. The single most important property of enzymes is their ability to increase the rates of reactions occurring in living organisms. This is adapted from Enzyme Activity, section 18.7, Introduction to Chemistry, General Organic and Biological. Okay, so here they're going to ask us, what is an enzyme? So B part 1. What is an enzyme? An enzyme, it's one of our standard definitions we had to learn off, is a biological catalyst. Done. Okay. Which type of biomolecule are enzymes? They are asking you there, are they made from proteins? Are they made from fats? Are they made from carbohydrates? Remember, biomolecules are any molecule found in a living thing. They are made from proteins. So enzymes from proteins. Okay. Part 3. Give 2 factors that affect enzyme action. They're talking about something that could speed up or slow down enzyme action. So we know that from our pH experiments, okay, and our temperature experiments. The answers are pH and temperature, okay, the ones that you've studied. So 2 things which affect enzyme activity is pH and temperature. Because remember, they change the structure of your enzyme, therefore they can denature it and they can affect its function. Okay. Name the parts of the ends. What is meant by the term specificity in relation to enzyme activity? Part 4. Specificity. This comes up all the time when you're talking about enzyme activity, all right? So specificity is how an enzyme specifically reacts with the substrate, all right? So what is meant by the term specificity? So specificity. So each enzyme only binds to one substrate. Therefore, it is specific to this substrate. This is due to its complementary shape. Okay, hopefully that's clear enough. Part 5. Give a detailed account of how enzymes work. Okay, so we're going to have to think of some of our enzyme substrate complex theories here to explain. So give a detailed account of how enzymes work. So let's think about this in a little bit more detail. So enzymes have a specifically shaped active site where, hopefully you can still see that, where substrates bind. Let's get a new page. So we've said that enzymes have a specific active site where substrates bind. Once you can see that, try and rearrange it so you can see it.